Operating systems concepts. An operating system is like a middleman between you and your computer. It helps you interact with the computer hardware and makes sure that all the different programs you use run smoothly. The objectives of an operating system are to execute user programs and simplify problem solving for users, to enhance the usability of the computer system, and to optimize the utilization of computer hardware resources. An operating system is like a manager for a computer. It's in charge of handling all the computer's resources, like memory and processing power. When different parts of the computer need the same resources, the OS decides who gets what, making sure everything runs smoothly and fairly. Also, the OS acts like a supervisor, making sure programs run correctly and that the computer isn't misused. The most important part of the operating system is called the kernel. It's like the main boss, always running in the background, making sure everything stays on track. An operating system is like the boss of your computer. It's the main software that keeps everything running smoothly. It takes care of the computer's memory and makes sure all the different programs and parts of the computer work together. The cool thing is, it lets you talk to the computer without needing to know all the technical stuff. Without an operating system, your computer wouldn't be able to do much at all. Learning about operating systems is important because they act as a bridge between us and the computer hardware we use. Operating systems do a lot of important jobs like managing files, memory, processes, and handling input and output. They also help control things like printers and other devices we connect to our computers. Understanding how operating systems work can help us use computers more effectively and solve problems when things go wrong. There are several popular operating systems used today. One of them is the Linux operating system, which includes distributions like Ubuntu, Fedora, and Linux Mint. Another widely used OS is the Windows operating system, with versions such as Windows 8, Windows 10, and Windows XP. Additionally, there's the Mac operating system, known for its Mac OS, iOS, and OS X variants. Another noteworthy system is the VMS, Virtual Memory System, exemplified by OpenVMS, which is a multi-user, multi-processing virtual memory-based operating system. A computer system is made up of four main parts: hardware, operating system, application programs, and users. The hardware includes things like the CPU, memory, and input-output devices, which give the computer its basic abilities. The operating system manages and organizes how all these parts work together, making sure everything runs smoothly for different programs and users. Application programs, like word processors or video games, are what we use to do specific tasks on the computer, using its resources. And finally, there are the users themselves, which can be people, other machines, or even other computers interacting with the system. The structure of a computer operating system is typically organized into several layers, each responsible for different aspects of system functionality. In a computer system, there are one or more CPUs, the brains of the computer, and device controllers. They all connect through a common bus, which acts like a highway allowing them to access the computer's shared memory. At the same time, CPUs and devices can work together, but they have to compete for their turn to use the memory. In a computer system, input, output, I/O, devices like keyboards and printers, and the CPU, which does the processing, can work at the same time. Each device has its own controller responsible for managing it, and each controller has a small storage space called a local buffer where it temporarily stores data. The CPU moves data between the main memory and these local buffers to keep everything running smoothly. Interrupts are like messages sent to the brain of the computer, the CPU, by things like keyboards or printers. They make the CPU pause what it's doing and switch to something else that needs attention, like when you stop reading to answer a question. When a device, like a printer, finishes its job, it tells the CPU it's done by sending an interrupt. In simple terms, when an interrupt happens, it shifts control to a special routine called the interrupt service routine. This routine is located in a table known as the interrupt vector, which holds the addresses of all the service routines. A trap or exception, on the other hand, is like a planned interruption created by software. It can occur due to an error or when a user requests something specific. So, in a nutshell, an operating system works based on these interrupts and traps. In computers, the smallest unit of storage is called a bit, and it can hold either a 0 or a 1. 8 bits together make up what we call a byte, which is the smallest convenient piece of storage in most computers. Another term you might hear is word, which is the basic unit of data for a particular computer system. A word can be made up of one or more bytes. For instance, if a computer has 64-bit registers and memory addressing, its words are typically 64 bits long, or 8 bytes. Computers often perform operations using their native word size, rather than dealing with just 1 byte at a time. Computer storage and data transfer rates are commonly quantified and managed using units called bytes and their multiples. A kilobyte, abbreviated as KB, represents 1024 bytes. Likewise, a megabyte, MB, equals 1024 squared bytes, a gigabyte, GB, equals 1024 cubed bytes, and a terabyte, TB, equals 1024 to the power of 4 bytes. For even larger quantities of data, a petabyte, PB, is equivalent to 1024 to the power of 5 bytes. However, in everyday language, computer manufacturers often simplify these numbers, stating that a megabyte is approximately 1 million bytes and a gigabyte is around 1 billion byte. It's important to note that when it comes to networking, measurements are typically expressed in bits, which is a different unit from bytes. Main memory, also known as primary memory, is the primary storage area that the CPU can directly access. It allows for quick access to data but is temporary, meaning it loses its contents when the power is turned off. Secondary storage, on the other hand, expands the storage capacity beyond what main memory can offer. Hard disks are a common form of secondary storage, with their disk surfaces divided into tracks and sectors for organizing data. Solid-state disks are another type of secondary storage, faster than hard disks and also non-volatile, meaning they retain data even when the power is off. In computer systems, storage is organized in a hierarchy based on factors like speed, cost, and volatility. To speed up processes, information is often copied into faster storage systems through a technique called caching. For example, the main memory of a computer can be seen as a cache for secondary storage like hard drives. Each device connected to the computer has a device driver, which helps manage input, output, I/O operations. These device drivers create a uniform interface between the device's controller and the core part of the operating system, known as the kernel. Cache is a special kind of memory that helps make getting data faster. Usually, the data needed for a task is kept in the main memory. But if some data is used a lot, it's moved to the cache memory temporarily. This way, the computer can access it quickly whenever it's needed. A device driver, also called a hardware driver, is a set of files that helps hardware devices talk to the computer's operating system. Without drivers, your computer wouldn't know how to send or receive data from hardware devices like printers. They're like translators that make sure everything works smoothly between your computer and its hardware. The storage device hierarchy is structured based on speed, with faster storage devices positioned closer to the CPU for rapid data access, while slower devices are typically used for bulk storage. At the top of the hierarchy are CPU registers and cache memory, which provide extremely fast access to data but have limited capacity. A general-purpose processor operating system is made for regular computers like PCs or workstations that we commonly use. Usually, these systems have just one general-purpose processor. The main thing we care about with these processors is how fast they can do computations. However, they're not meant for really fast tasks that need immediate responses. A multiprocessor operating system means using two or more central processing units, CPUs, in one computer. These CPUs work closely together, sharing things like the computer's bus, memory, and other devices. A multiprocessor operating system, also called a parallel system or tightly coupled system, offers some advantages. First, it boosts throughput, meaning it can handle more tasks at once. Second, it enhances reliability by having fault tolerance, which means it can keep working even if there's a problem. There are two main types of multiprocessor systems. In asymmetric multiprocessing, each processor has its own specific job to do. In symmetric multiprocessing, each processor can do any task. Symmetric multiprocessing offers balanced resource distribution, scalability, and fault tolerance, while asymmetric multiprocessing provides flexibility for optimizing performance but may be less scalable and resilient to failures. A dual-core processor is like having two brains in one computer chip. Each brain, called a processor or execution core, works together inside the same chip. These processors each have their own cache and controller, which help them work just as well as a single processor. Clustered operating systems are similar to parallel operating systems because they have more than one CPU, or brain, just like having more than one computer working together. When you put two or more computers together, it's called a cluster. In a cluster, these computers share the same storage and work together as a team. Usually, in clustered operating systems, they share storage using something called a storage area network, SAN. Operating systems have several important properties that are helpful to understand. First, there's batch processing, where the computer processes a group of tasks all at once, like baking cookies in batches. Then, there's multitasking, or time sharing, which means the computer can work on multiple tasks at the same time, like when you switch between different apps on your phone. Multiprogramming is similar, allowing the computer to work on several programs simultaneously. Real-time systems are crucial for tasks that need immediate responses, like controlling traffic lights. Finally, there's the distributed environment, where computers work together over a network, like when you share files between devices. Understanding these properties helps us grasp how operating systems manage tasks and resources effectively. Batch processing is a method used by the operating system where it gathers programs and data into groups, called batches, before starting the processing. This approach has several benefits. It reduces the idle time of the batch system, making it more efficient. It can handle large, repetitive tasks easily. And it shifts much of the workload from the operator to the computer, streamlining operations. Multitasking is when the CPU does many jobs at once by switching between them really quickly. This means users can work on different programs at the same time. Some examples of multitasking operating systems are Linux, Windows 8, and Windows 10. Multiprogramming is when the processor shares its time between two or more programs that are in the computer's memory together. But here's the thing. Only one program can use the CPU at a time to do its work, while the rest have to wait their turn patiently. This setup helps the CPU stay busy all the time, because there's always a program ready to go. So, multiprogramming basically makes sure the CPU is never sitting idle, which is pretty cool. Advantages of the operating system include making sure the CPU is used effectively and efficiently, which means it's not sitting idle. This helps users feel like they can run multiple programs at the same time without slowing down their computer. Real-time systems are often special purpose and built into devices. In these systems, the operating system has important jobs to do. It reads information from sensors and responds to it quickly. It's crucial for the operating system to react to events within set time frames to make sure everything works correctly. In a distributed environment, there are many separate CPUs or processors in a computer system. The operating system, OS, in this setup does several things. First, it spreads out the work among these different processors. Second, each processor has its own memory and doesn't share it with others. Third, the OS takes care of making sure these processors can talk to each other. They use different communication lines to share information. An operating system has many important jobs to help your computer run smoothly. It manages your computer's memory, making sure programs have enough space to work properly. It also handles how your computer's processor works, so tasks get done efficiently. The OS takes care of devices connected to your computer, like printers or keyboards. It helps organize and keep track of your files, making them easy to find when you need them. The OS also looks after security, keeping your computer safe from viruses and hackers. It controls how well your computer performs and keeps track of what tasks are being done. Plus, it can help find and fix errors that might pop up while you're using your computer. Memory management is all about making sure the main memory, which is a quick storage that the CPU can directly access, has what it needs to run programs smoothly. This means putting the instructions and data that a program requires into memory. Memory management decides what stays in memory and when it gets there, ensuring that programs have what they need to run properly. The operating system does a few important things to manage memory. It keeps track of the computer's main memory, known as primary memory, figuring out what parts are being used by which programs and what parts are free. In situations where multiple programs are running simultaneously, the OS decides which program gets how much memory and when they get it. When a program needs memory, the OS gives it some. And when a program is done with memory, the OS takes it back and makes it available for other programs to use. This helps the computer run smoothly and efficiently. In a system where many programs run at once, the operating system, OS, makes choices about which program gets to use the processor, the main part of the computer that does the work, and for how long. This is called process scheduling. The OS keeps an eye on the processor and what each program is doing. There's a special program called the traffic controller that handles this job. It decides which program gets to use the processor and when. When a program doesn't need the processor anymore, the OS takes it away and gives it to another program. Device management is an important job of the operating system, OS. It handles how devices, like printers or keyboards, talk to the computer using special software called drivers. The OS keeps a list of all the devices connected to the computer. A special program called the I/O controller is responsible for this task. The OS also decides which program gets to use a device, when it gets to use it, and for how long. It makes sure to give devices out in a smart and efficient way. When a program is done using a device, the OS takes it back and makes it available for other programs to use. File management involves organizing files in a system so they're easy to find and use. In a file system, files are grouped into directories for simpler navigation. The operating system handles various tasks for managing files. It keeps track of details like where files are stored, how they're used, and their status. It also decides who gets to use resources like memory and storage space, and then assigns and frees up these resources as needed. Thank you for watching.